Polymer. Introduction. The word polymer is coined from two Greek words. Poly means many and mer means unit or part. The term polymer is defined as very large molecules having high molecular mass. These are also referred to as macromolecules, which are formed by joining of repeating structural units, are derived from some simple and reactive molecules known as monomers, and are linked to each other by covalent bonds. This process of formation of polymers from respective monomers is called polymerization. The transformation of ethane to polythene and interaction of hexamethylene diamine and adipic leading to the formation of nylon 6,6 are examples of two different types of polymerization reaction. Classification based on source. Under this type of classification, there are three subcategories. 1. Natural semi-synthetic and synthetic polymers. Classification based on structure of polymers. There are three different types based on the structure of polymers. Classification based on mode of polymerization. Addition polymers. The addition polymers are formed by the repeated addition of monomer molecules possessing double or triple bonds. Example, the formation of polythene from ethane and polypropene from propene. However, the addition polymers formed by the polymerization of a single monomeric species are known as homopolymers. Example, polythene. The polymers made by addition polymerization from two different monomers are termed as copolymers. Example, Buna S, Buna N, etc. Condensation polymers. The condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. In these polymerization reactions, the elimination of small molecules such as water, alcohol, hydrogen chloride, etc. take place. The examples are terylene, nylon 6, nylon 6, etc. For example, nylon 6 is formed by the condensation of hexamethylene diamine with adipic acid. Classification based on molecular forces. The polymers are classified into four subgroups as shown above on the basis of the magnitude of intermolecular forces present in them. Types of polymerization reactions. Free radical mechanism. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating a new and larger free radical. This step is called chain initiating step. As this radical reacts with another molecule of ethene, another bigger sized radical is formed. The repetition of this sequence with new and bigger radicals carries the reaction forward, and the step is termed as chain propagating step. Ultimately, at some stage, the product radical thus formed reacts with another radical to form the polymerized product. This step is called the chain terminating step. The sequence of steps may be depicted as follows. Polyamides, preparation of nylons, nylon 6. It is prepared by the condensation polymerization of hexamethylene with adipic acid under high pressure and at high temperature. Nylon 6. It is obtained by heating caprolactam with water at a high temperature. Phenol, formaldehyde polymer. These are obtained by the condensation of reaction of phenol with formaldehyde in the presence of either an acid or a base catalyst. The reaction starts with the initial formation of O and or p-hydroxymethylphenol derivatives, which further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product could be a linear product. Novolac used in paints. Melamine, formaldehyde polymer. Melamine is formed by the condensation polymerization of melamine and formaldehyde. Copolymerization. Copolymerization is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize and form a copolymer. It contains multiple units of each monomer used in the same polymeric chain. For example, a mixture of 1,3-butadiene and styrene can form a copolymer. Natural rubber. Rubber is a natural polymer and possesses elastic properties. It is also termed as elastomer and has a variety of uses. It is manufactured from rubber latex, which is a colloidal dispersion of rubber in water. This latex is obtained from the bark of rubber tree and is found in India, Sri Lanka, Indonesia, Malaysia, and South America. Vulcanization of rubber. Natural rubber becomes soft at high temperature and brittle at low temperatures and shows high water absorption capacity. It is soluble in nonpolar solvents and is non-resistant to attack by oxidizing agents. This process consists of heating a mixture of raw rubber with sulfur and an appropriate additive at a temperature range between 373 K to 415 K. On vulcanization, sulfur forms crosslinks at the reactive sites of double bonds and thus the rubber gets stiffened. Synthetic rubbers. Synthetic rubber is any vulcanizable rubber like polymer which is capable of getting stretched to twice its length. However, it returns to its original shape and size as soon as the external stretching force is released. Thus, synthetic rubbers are either homopolymers of 1,3-butadiene derivatives or copolymers of 1,3-butadiene or its derivatives with another unsaturated monomer. Preparation of synthetic rubber like neoprene and Buna-N are shown above. Biodegradable polymer. Aliphatic polyesters are one of the important classes of biodegradable polymers. Some important examples are given above.